Logarithms, and I don't mean this log, but I mean a quantity representing the power to which a fixed number the base must be raised to produce a given number. So what does that mean? But first, why? There was no inverse for exponential functions, so they had to create this thing called log. Alright, it's an inverse of an exponential function. So if y equals b to the power of x, then log base b of y would be equal to x. Then there's a good way of remembering this. Base to the outie is the any, so y equals b to the x, b would be the base, y would be the outie, and x would be the any. So you come up with this. There are 5 properties of log: product property, quotient property, power property, inverse property, and change of base formula. The first one's product property, which is logarithm of a product is a sum of the logs of its factors, and this is the formula. Log base b of m times n is equal to log base b of m plus log base b of n. Now I'll give you 3 examples of this formula. Log base 5 of 3 times 4 is equal to log base 5 of 3 and plus log base 5 of 4. Log base 7 of 4 times 5 is equal to log base 7 of 4 plus log base 7 of 5. Log base 3 of 3 times 8 equals log base 3 of 3 plus log base 3 of 8. You can always distribute these 3 times 4, and even if you multiply it out into 24, you can still distribute it. But you gotta be careful, because you can't do this. Log base b of m times log base b of n is not equal to log base b of m plus log base b of n. That's being unproductive with the product property. Don't do that. Next up is the quotient property, and it's the log of a quotient is equal to the difference of the numerator and denominator, which means that log base b of m divided by n is equal to log base b of m minus log base b of n. You should quote me on it. Log base 3 of 4 equals log 3 minus log 4. Now here you can see an example of a common log. Common log is where it's base 10. And then log base 2 of 5 divided by 9 is equal to log base 2 of 5 minus log base 2 of 9. Log base 5 of 13 divided by 4 is equal to log base 5 of 13 minus log base 5 of 4. But you gotta be careful again. Alright, log base b of m minus log base b of n is not equal to log base b of m divided by log base b of n. Alright, the third property is power property, which means that the log of a power is equal to the power times the log of the base, which means that log base b of m to the power of n is equal to n times log base b of m. So log base 3 of 4 to the power of 5 is equal to 5 times log base 3 of 4. Log base 3 to the power of 10 is equal to 10 times log base 3. Log 3. Log base 7 of 2 to the power of 4 is equal to 4 times log base 7 of 2. Hope this empowers your brain. Alright, the fourth property is the inverse properties, which is the inverse of an exponential logarithm function is an exponential function. So log base b of y equals to x equals log b to the power of x equals to y. So log base 2 of 16 equals 4 would be the same as 2 to the power of 4 equals 16. Log base 3 of 9 equals 2 would be the same thing as 3 to the power of 2 equals 9. Log base 5 of 625 equals to 4 would be the same as 5 to the power of 4 equals 625. Well, I don't have a pun for this one, so we're just going to move on. So the next one is a formula, but it's also a property. It's the change of base formula, which is log base a of b is equal to log base c of b divided by log base c of a. So you can have any different base as c, and it'll still be the same thing. So log 5 is equal to log base 3 of 5 divided by log base 3 of 10. Log base 3 of 5 is equal to log 5 divided by log 3, and log base 5 of 2 is equal to log base 7 of 2 divided by log base 7 of 5. Always, you want to make sure that log base 5 of 2, make sure the 2 is in the numerator and the 5 is in the denominator. So that's it. I hope you learned something about logs. Bye. Bye. Oh wait, don't forget to like and subscribe.